In this video, we will study two color balls combination probability, but the sampling size will be 4. An urn contains 12 blue balls and 8 red balls. 4 balls are picked up at random without returning the balls to the urn. First question, what is the number of all possible outcomes or the number of elements in the sample space? First, we number the balls to make them distinguishable. So we number red balls from 1 to 8 and blue balls from 1 to 12. Now, even though we have these two balls having the same name 1, but one is blue and one is red. Or we can number these balls from 1 to 20 to give them distinguishable identity. And now we can answer the question. The number of elements in the sample space for the case of any order can be computed from the combination formula under the condition of withdrawing without replacement. So we have 20 objects and we are sampling 4 objects out of them. So we use the combination formula and we substitute n by 20 and r by 4 and we get 4,845 possible outcome of unordered elements or unordered sampling. Question number 2. What are the possible joint outcomes from the standpoint of colored balls? So let B represents drawing blue ball and R represents drawing red ball. We will use tree diagram starting with 12 blue and 8 red. So in the first draw we may get blue or red and the remaining balls will be 11 blue and 7 red. And we have to emphasize here that we are drawing without replacement, and that's why we can use the combination formula which assumes no replacement. For the second draw we may also have blue or red, and the reason why we have here 11 blue and 7 red, and now the remaining balls are 10 blue and 6 red. So again we may withdraw blue or red because we have 10 blue remaining and 6 red remaining here, and for the third draw the remaining will be 9 blue and 5 red. For the fourth draw we may also get blue and red and the remaining balls would be 8 blue and 4 red. So we have here 4 draws already completed, and now we need to get all possible joint outcome. So for this pass here we have 4B, for this pass here we have 1B and 3R, and so on, and these are all the possible joint outcome. Now we will classify them according to the number of blue and red balls in each joint outcome. So this is the total joint outcome, and now we isolate them and we start grouping them according to the number of blue balls and red balls. So first we have the subset of 3 blue, the subset of 2 blue, and the subset of 1 blue only. So let's arrange them concisely. For the first subset, and now the second subset, and the third subset. We turn them around and we place them in order. Now they have taken the final shape. So these events or these subsets, they create the sample space in the sense that their union creates the sample space. So that means they create partition in the sample space. And here we have each event with its name on it. So here we have picking 4 blues, picking 3 blues and 1 red, and so on. Question number 3. How many 4 blue balls can be withdrawn? So we are withdrawing only from the blue subset. So we may get the first one, the second, the third, and the fourth. And now we have a sampling of 4. So we are picking 4 out of 12, and that is 12 combined 4, and this is equal 495. Question number 4. How many 3 blue and 1 red ball can be withdrawn? Or in how many ways we can withdraw 3 blue and 1 red? So here we have the urn, and we have to pick 3 blue out of 12. So this is the first, the second, the third, and we have to pick 1 out of this red subset. And now we have a sampling of 4. So we are combining 3 out of 12 blue, and that can be done in 12 combined 3, and we are combining 1 out of 8 red, and that can be done in 8 combined 1 ways. But before we continue, let us remember the multiplication principle of 2 events or sets. If event U has U objects and event V has V objects, then the product U times V or V times U represents the occurrences of both events in any order. And this is the case of the multiplication principle where order is not important. So there are cases for the multiplication principle where order is important, such as this case number 1 here, and number 2, and number 4. But for our case, we need the case of no order, since combination implies no ordered element. So we apply case number 3 for our question. So we apply the multiplication principle on these 2 sets, this set here and this set here, and this is the principle, and we get 220 times 8. So there is 220 ways of picking 3 blue out of 12, and there is 8 ways of picking 1 red out of 8 red balls, and their multiplication is 1760. So that means we have 1760 ways to compose an element which consists of 3 blues and 1 red. Question number 5. How many 2 blue and 2 red balls can be withdrawn? So here is the urn, and we have to get 2 blue and 2 red, and now we have an element of 4 objects. So what are the number of ways of picking 2 blue out of 12? That would be 12 combined 2. And what are the number of ways of picking 2 red out of 8? That would be 8 combined 2. Now we use the multiplication principle to create an element of 2 blue and 2 red. So we multiply them together according to this principle here, and we get 66 times 28, and 66 is the number of ways of picking 2 blue out of 12 blue. 28 is the number of ways of picking 2 red out of 8, and that would be 1848. So we have 1848 ways of picking both 2 blue and 2 red at the same time. Question number 6. How many 1 blue and 3 red balls can be withdrawn? So that's exactly as we did before. So we pick 1 blue and 3 red in order to compose one element of 1 blue and 3 reds. So number of ways to pick 1 blue is 12 combined 1. Number of ways to pick 3 red out of 8 is 8 combined 3. And now to compose them together, to know the number of ways of composing them together, we use the multiplication principle. So we use this principle here, and we get 12 times 56 equal to 672 possible combination. Question number 7. How many 4 red balls can be withdrawn? So we are picking up 4 red, and these are the 4 red, and now we have 1 element, and number of ways of doing that is 8 combined 4. So we are combining 4 red out of 8 red, and this is equal to 70 possible combination. So now let's place this event with their possible outcome in the sample space. So the first event, 4 blue with 495 possible outcome, and the second event is 3 blue and 1 red with 1760 possible outcome, and this event, 2 blue and 2 red with 1848 outcome, 1 blue and 1 red 672, 4 red 70 possible outcome. Question number 8. What is the probability of drawing 4 blue balls? So here we have 4 blue balls with 495 possible outcome. We divide that over the total number of elements in the sample space, and we get its probability. Question number 9. What is the probability of drawing 1 red and 3 blue balls? So this question can be asked in different ways. So here we have the sample space with the total possible outcome for this event 1760, and we can ask this question as what is the probability of drawing exactly 1 red. So this is the event for withdrawing exactly 1 red, or what is the probability of withdrawing exactly 3 blue, or what is the probability of withdrawing 1 red and 3 blue. So we divide 1760 over total number of elements in the sample space, and we get the probability 0.36. Question number 10. What is the probability of withdrawing 2 red balls and 2 blue balls? So this is the event, and it can be asked as what is the probability of withdrawing 2 red exactly. So this is the event 2 red exactly, or they may ask what is the probability of withdrawing 2 blue exactly, or 2 red and 2 blue. So we divide 1848 over 4845, and we get 0.38. Question 11. What is the probability of drawing 3 red and 1 blue ball? So this is the event here, and as we did before exactly, we divide the number of favored outcome, which is 672, over total number of elements in the sample space, and we get 0.138. Question number 12. What is the probability of drawing 4 red balls only? Or somebody may ask what is the probability of withdrawing no blue balls. So that would be this event here. So the probability is 70 over 4845, and that is 0.014. Question 13. What is the probability of drawing at least 2 blue balls? So here we have the sample space, and at least means either 2 blue or more. So we may pick 2 blue and 2 red, 3 blue and 1 red, or 4 blue and no red. So these are disjoint events, and their union create the event we are looking for, which is picking at least 2 blue balls. Now the probability is the sum of these individual probabilities of these events. So probability of at least 2 blue is probability of picking 2 blue or 3 blue or 4 blues, and that is equal to 0.84 or 84%. Question 14. What is the probability of drawing at most 2 red balls? So the maximum number of balls to be withdrawn must be 2 or less. So we may pick 2 red or 1 red or 0 red. Actually, this is exactly the same previous question 13 but written in a different way. So these events are disjoint, and their union would create the event we are looking for, which is at most 2 red balls to be withdrawn. So the probability is picking either 2 red, 1 red or 0 red, and that is equal to the sum of these individual events. So the first event, 1848 divided by total number of elements in the sample space plus 1760 over total number plus 495 over the total number, and that is equal to 0.84. That's exactly question 13 but written in a different way. If we recall question 13, the probability of at least 2 blue exactly equal to the same sum of these events in question number 14. So we can conclude that the event which is at most 2 red is equivalent to the event at least 2 blue in this problem here. Question 15. What is the probability of drawing 2 red and 2 blue or 3 red and 1 blue? So or here means union, and this union is the union of 2 disjoint events, and the probability in this case will be plus. So or means union and means the sum of probabilities if these 2 events are disjoint events. So this is the event of drawing 2 red and 2 blue, and this is the event of drawing 3 red and 1 blue. Their union is the event 2 red and 2 blue or 3 red and 1 blue. So the probability of this event equal the probability of the sum of probability of each individual event, and that is equal 0.52. Question 16. What is the probability of drawing either 3 red or 3 blue? So here is the sample space, and this is the event of drawing 3 red. We have 3 red here in each one, and this is the event of drawing 3 blue only. So their union would create the event we are looking for, which is 3 red or 3 blue, and these 2 events are disjoint events. So the probability of this event is the sum of probability of each individual event representing it, and that is equal to 0.50.